Hi everyone, so now we're going to be talking about sums of geometric series. Once again, the difference between a sequence and a series is that a sequence is never ending. Like it has that ... at the end, so it means that it could go on forever and ever, where a series has an ending point. There's only so many terms in a series. And so because there's only so many terms in a series, then we can find the sums of them, which means that we take all of the terms and then add them together. So for sums of geometric series, there's two different formulas we can use. The first formula is S sub n is equal to a1 minus a1 times r to the power of n all over 1 minus r. Or you can use the formula S sub n is equal to a1 minus an times r divided by 1 minus r. And you choose, it does not matter which formula you choose, they will give you the same answer. But sometimes it's easier to use one over the other depending on what information you've been given in the question. So let's go ahead and get started. For the first example, the information we have is that a sub 1 is equal to negative 2, a sub n is equal to negative 31,250, and r is equal to negative 5. So in this case, I have my first and my last terms in r, which tells me that I want to use that second equation. While I potentially could use that first equation and figure out what n is, it's going to be way easier for me to just take the information I already have and use it in the equation that's easiest, which is the second equation. So I'm going to say S sub n is equal to a1 minus an times r over 1 minus r. Now let's replace what we know. So it's going to be a s sub n, and we don't know what n is, so I'm just going to leave it as n, which is totally fine, is equal to a1, which we know is negative 2, minus an, which is negative 31,250, times r, which is negative 5. Notice that I put everything in parentheses. Sometimes it's easiest to just, every time I plug a number in for a variable, to plug it in inside parentheses, just so your calculator reads it right. And then on the bottom we have 1 minus r, which is negative 5. Okay, now I'm going to plug all of that into a calculator, and I will get, let's see, 250 times. I'm going to get the S sub n, or the sum of all of those terms in between the first and the last term, plus the first and last term, is negative 26,042. So that's how we use one of those equations. Now let's look and see how we use the other equation. So the the second example gives us this information. The a sub 1 is equal to 4, r is equal to 3, and n is equal to 10. So once again, I'm going to scroll up a little bit here so we can see these formulas. We have the first term, the r and the n. Because we don't have the a sub n, it's going to be really hard for us to use that second equation. Instead, we're going to use that first equation. So I'm going to just rewrite it down here. S sub n is equal to a sub 1 minus a sub 1 r to the power of n, 1 minus r. Okay, now let's plug in what we know. So this time I do know what n is, so I can replace this n and this s sub n with 10. And then you don't have to, you can leave it as s sub n. It doesn't really matter for our answer. Then our a sub 1 is 4 minus another 4, because we have a sub 1 again, times our r, which is 3, to the power of n, which is 10, all over 1 minus my r, which is 3. All right, so now all we have to do is plug it into a calculator, which gives me, oh shoot, 1 second. Okay, which gives me that S sub 10 is equal to 118,096. All right, so that's how we use the other equation. Now for examples 3 and 4, they use a funky little symbol. It's called sigma. We learned about it in that arithmetic series formula. And remember, sigma stands for sum, which means that I'm going to find the sum between the first term and the 9th term of this formula that they have, and I'm going to put that 2 in parentheses. You don't necessarily have to have it in parentheses, but it's way easier if you do. So I want to find the sum between the first term and the last term of this equation, this negative 3 times 2 to the power of n minus 1. So there's a couple of different ways that we can do this, but I'm going to show you kind of the easiest way. When your geometric equations are set up like this, it's actually really, really, really easy to find some terms. Instead of plugging numbers in, this first number, like the very first number that doesn't have any exponents, is your a sub 1. And then the number inside the parentheses, or the number that does have the power of n minus 1, is your r. So I have my a sub 1 and my r, and then if you remember from the arithmetic series, that top number right here is your n. So we have my a sub 1, my r, and my n. Because I have all of those numbers, what I can use, let me scroll up here, I can use this equation right here. Let me just box it out right here. Because that gives me everything, I already have everything for that equation. So let me just rewrite it down here. All right, now let's plug in what we know. So I'm going to have S sub 9, because I know my n is 9, because that's the very top number on my sigma, equals a sub 1, which is -3, minus a sub 1 again, times my r to the power of my n, all over 1 minus my r. Okay, now let's plug that sucker in. Which gives me that S sub 9, or the sum of the first 9 terms, would be -1533. All right. So now, let's do the fourth example. And the fourth example is the same sigma notation. So in this one we have n equals 1 on the bottom, which just means we're starting from the first term, and then 8, which means we're going to find the first 8 terms of 5 to the power of n minus 1. Now, this one's slightly different, because if you look at the third example, I'm going to just scroll up here, you have two numbers that are like bigger. You have a number, the -3 is like the first number, then that 2 is the one with the powers to it. So we can still use that same stuff for this example, but for this example, I'm going to just show you another way to rewrite it. Oh, sorry. Another way to rewrite it would be like this. N is equal to 1 and 8, but then I'm going to put a 1 times 5 to the power of n minus 1. So if I don't have a number in front of the number with the exponent, I can just represent that as 1. And it totally works. So what this tells me is this is my first term. This is my r, like the last time, and then this is my n. So I have all of that information for that formula, which is S sub n is equal to a sub 1 minus a sub 1 times r to the power of n, all over 1 minus r. Okay, so now let's plug that in. We're going to have S sub 8, because we know our n is 8, is equal to 1 minus 1 times my r, which is 5, to the power of 8 over 1 minus 8. Oh, not 8. What am I saying? That's silly. 1 minus r, and r is 5, not 8. Okay, so now let's plug that into a calculator. Which would give me that the sum of the first 8 terms in the sequence is 97,656. Okay, and so there we have it. This is how we use the formulas to find sums of geometric series.